The Virtex-4 device has chip sync technology built into every I/O pin. Chip sync can be used to control the delay of the given I/O pin to eliminate setup and hold time issues. The Virtex-4 software tools provided by Xilinx are low cost. They make design of the Virtex-4 easy. They have architecture wizards for chip sync, extreme DSP, DCM, and memory interface generation. ChipScope Pro is also a tool provided for debugging analysis, and they include plan ahead tool, which would allow partial reconfiguration of your FPGA, saving many hours of configuration time. Defining your FPGA operation is typically handled with Verilog or VHDL description. However, Mentor Graphics offers a tool which allows description in C. Their tool is called Catapult C. It takes a C functional description and produces a Verilog or VHDL description. The HDL code is tailored to your FPGA, and since this tool can be instructed to implement parallel DSP structures or serial DSP structures, which will allow you to experiment with the amount of resources available in your FPGA and the speed of your operations. The PMC-LX SX has 4 main board clocks, all synchronized to within 250 picoseconds. These clocks include the local clock, which is used for local bus, the CPLD clock, which is used for the CPLD and configuration of the FPGA, the SR clock, which is the SRAM clock, and the FPGA clock. The default clock frequency is 66 MHz, although DCM within the FPGA and the user row register bit can be used to change the clock frequency. This frequency can be anything in the range between 10 MHz and 66 MHz. Also present on the PMC-LX SX is a 200 MHz low jitter clock, and this clock is provided for clocking the double data rate SDRAM logic. Dual port memory is available on the PMC-LX SX. This memory density is 256K by 32 bits. One port of this dual port memory connects directly to the PCI bus through the PLX chip. The other port connects directly to the FPGA. Useful for DMA transfers. Burst transfers up to 264 megabits per second is possible. Double data rate SDRAM is available on the PMC-LX SX as well. The densities of these devices is 32 meg by 32 bits. Internal FPGA controller clock is 150 MHz. Data transfer rates up to 300 meg 32-bit words per second is possible, since data transfers on both the rising and falling edge of this 150 MHz clock. The example design uses burst length equal to 4, and the controller performs auto refresh automatically. The Xilinx memory interface generator tool provided by Xilinx was used to generate this controller. Power supplies present on the PMC-LX to power the Virtex-4 at 1.2 volts uses a two-phase DC to DC, which provides typically 7 amps. This dual output provides two outputs 180 degrees out of phase, which results in reduction in the ripple amplitude for a nice clean power supply signal. Temperature sensor built into the Virtex-4 is located roughly in the middle of the device, and its temperature reading was given here at 53 degrees C. Thermocouple readings were also taken at 3 other points on the board. Point 1 was near the CPLD, which is the next hottest point at 45 degrees C, and near the double data rate SDRAM Thermocouple reading number 2 was measured at 40 degrees C. The coolest spot on the board was near the front I/O mezzanine connector at 37 degrees C. The EDK includes the user's manual, a new Getting Started document, and in the new Getting Started document it walks you through the Xilinx Foundation tool and edit to the supplied VHDL code for regeneration of the MCS configuration file. Also, the Getting Started document walks you through development of a Windows application using the Acromag PCISW control software. You will be able to develop a high-level interface to the board. This engineering design kit also includes the VHDL, the example design files, constraint files, and configuration files for each of the PMC-LX, SX boards. This concludes the overview of the PMC-LX product. Thank you.